Hello everyone, I'm recording this video on Monkey See Monkey Do Linux, which is a didactic Linux distribution we've been covering of how to build one absolutely from scratch within this YouTube series this video is part of. And today I'd like to introduce a big milestone I've reached, which is installing Xorg X server so that now I can record the video not in the emulator. Like earlier, what I've been doing, I was just running the QEMU emulator and the Linux Mint, and then I was running the Monkey See Monkey Do Linux in there, and I was using the Xfbdev Xorg server, not the Xorg, and that's how I've been recording. So now this runs on the real hardware, my old laptop, Dell Inspiron 3, and now it's the native resolution. It should be 1366 by 768 pixels. And this is indeed Xorg X server running here. Because with Xfbdev, this wasn't really possible to. Well, it was actually possible to record things, but it wasn't possible to edit the video using the shotcut editor, which I'm using, which I probably can demonstrate as well. And the recording speed was very, very bad, so it was like lagging a lot. So because there was no hardware acceleration. So just a few words in regards to the difference between the Xfbdev and Xorg. So Xfbdev is sort of a software rendering thing where it writes the graphics to /dev/fb0, the frame buffer device, while the Xorg writes to the device like EDP1 screen, for instance. So it's using the drivers to talk to graphical card, if any. I'm having the built-in Intel video card here. So anyways, just goes much faster. And also some applications like, for instance, the shotcut video editor do rely on Xorg, and without Xorg, it's not going to be working. So I've spent countless hours and basically days to debug everything, to make everything working properly, and I even have some simple ALSA setup here, so I have a very basic way to play sounds, which I can probably demonstrate as well a bit later. But for now, I'd like to focus at what pitfalls have I been through during trying to install Xorg, and how was that resolved eventually. So like you can so reproduce the steps if you like. Yeah, I really doubt somebody will, but anyway. So let me just open this part in the Firefox. So yeah, by the way, probably I will start by showing how the gestures are working. So I have a touchpad here. It's got ElnTech touchpad, PS2 touchpad. If I just put two fingers on the touchpad and scroll down and scroll up, this is what's happening on the screen. So also, if I just take the terminal window, I can click the button and then move. Well, this seems trivial, right? But without the specific drivers, it's not working that way. So with Xfbdev stuff, it wasn't working that way. I could neither scroll nor use the right button click. And I had issues with dragging and dropping the windows because there were no any specific drivers, but we'll get to that a little bit later. So here in the README file under the GitHub.com Monkey See Monkey Do Linux, I have some basic draft overview of what needs to be done to get Xorg installed if you have installed Monkey See Monkey Do Linux on the hard drive. So I've been trying this on QEMU, but unfortunately for some reason it doesn't work, and doesn't seem to be possible to debug this there, because when I use the rescue key combination to get off the hanging Xorg, which hangs if there is no input or some other issues there, it just restarts the eventually restarts the Xorg on not only under the QEMU in the emulated system, but on my Linux Mint, where I've been running this earlier when I was running things in the QEMU emulator. So that wasn't really the case. So I cannot debug that. Well, maybe I could have used some virtual machine to like forward the its key bindings, but again, if you're dealing with the emulated stuff, then like whatever kernel related, kernel messages related combinations like rescuing things, it's just gets listened by the kernel itself directly, and in the host environment, not in the emulated environment for some reason. So that's why it's not really that easy, not trivial to debug things under the QEMU. So the only way I managed to install Xorg eventually is on the real hardware, on the laptop I'm currently recording this video on. So what are these steps? So, first of all, I needed to, as always, I needed to recompile the kernel to pick up the proper video drivers specific to my particular hardware. But yeah, this has been covered in the session where probably the very first video in a series, like how to compile and configure a Linux kernel. So all the pitfalls, hints, and ideas, how to proceed. So once I did make sure that my kernel does support all the hardware, then I needed to change the very base of the monkey do Linux itself. I will show this as well. And when everything has been changed, let's say the current state of monkey do Linux that you can download from my GitHub here. Just try to show where exactly. Here, monkey do Linux. It's available over in here. So this, you don't quite really need to install things on the hard drive to try to play around with X. Oh, well, actually, it's hard to say. It's whether you have to. Well, it's possible to boot from the this ISO. So this, the very simple, the very small ISO, just contains the base and no other packages, but it has some install scripts to install the base packages and to install the X server related packages. But you cannot install the system using this ISO. To install the system, there is the specific script called make install ISO, which is available under the sources. So this is the make install ISO, which downloads that ISO and asks you a couple of questions, like in which partition your Linux system is about to reside, like devsd2, for instance, or somewhat similar. So yeah, and then you can, it's really easier to have the system installed and then just playing around with it, because you can download many times, because if you can, just easier to debug when the system is actually installed. But anyway, let's say the system is installed. In this case, what I forgot to do, I really should have provided the var log folders to the root file system. Just forgot to do this. Well, maybe I'll do this one day, then I'll need to remove this line from the README. And then we need to, so apart from those packages that has been installed when the Xfbdev thing has been installed, which can be obtained the following way. So this has been covered within the previous video. So like just installing everything and installing the X server. Probably. Do we still need to connect to network? I don't remember. Maybe I did this automatically. Maybe not. Maybe. Well, so many things in my head I don't remember already. Anyway, so when the Xfbdev is installed and when you've reached the state described exactly in the previous video under this series, then a few other packages to install would be to install the Xorg, Xorg 3D, x86 video Intel is specific to my embedded video card. If you have something different, then like the corresponding x86 and whatever vendor you have. Here, you can find those in the repository of tinycore Linux, which can be reached at tinycore Linux. I don't have it here. Come on, I should have had this here. Okay, just http tinycorelinux.net/14.x /x8664 tcz. come on, no, what G? What are you talking about even? No. Here. What? You must be kidding me. Okay, just lots of typos. Yeah. It's not HTTPS, it's HTTP. Yeah, so here is the list of the packages that you have. So if you search for xf86, yeah, slash video, so some other options are available. So you can try Visa if nothing works, or Xfbdev. It's not going to be as fantastic as with the native drivers. But anyway, if you have the ATI card, this would probably be an option for you. So yeah, it's really like a good luck scenario. So just good luck configuring things on your own. So that's always specific to these class of DIY Linux distributions, like do-it-yourself Linux things like that. And once this package has been installed, startx should do the trick. Yeah, and I recommend not to install them manually, but to, before installing them, to make them part of the install xfbdev script, which can be found. If I just go to install xfbdev, so this script, because so to make these dependencies run by this script, I recommend to put packages to this package list, right, which is being read by this script, because what happens here, what's important happening here is that you need to change the group from native staff from Technical Linux to Monkey See, Monkey Do, which is available on the Monkey See, Monkey Do system, under all of the user files under the user local bin, meaning not the binary files obviously, but the shell scripts. Yeah, because otherwise it's not going to work properly. So yeah, I should have probably managed this under the README as well. But again, I'm not really doing this for for other people, but rather like a reminder for my very own self. If I do this like one more time, one day, then so that I remember the steps I've been through. Okay. So yeah, because when you install Xorg, it would just override the startx script, for instance, and again the permissions there would be drop back to Technical TC user and staff group, but we need the Monkey See, Monkey Do user and Monkey See, Monkey Do group to make things working properly, because otherwise the permissions would mess up things most likely. And then if you do run the startx, then everything should work. I can just show you my current xsession that eventually gets executed by the startx script. So here I'm running the Xorg, now listen TCP, and then the rest is just like in my previous configuration. So previously with xfbdev, I had the xfbdev here. Well, optionally, you can try to change the sysconfig xserver to xorg, but even if you leave it as xfbdev, which would most likely be the case if you run from the ISO, install things on the hardware, this shouldn't be the issue, because if the startx script finds the xorg using the which command, it would then automatically switch to xorg. That's the nature of the startx script that has been downloaded along the X server from the Technical Linux repository. So hopefully that makes sense. Okay, and this is just nothing compared to what was the real issue, why I couldn't set up X server for, I don't know, like 3 days in a row maybe. So the idea is like, yeah, I should have really go. I've been diving deeply into the configurations. I spent countless hours talking to ChatGPT, trying to debug things like why it's not working, trying to play around with different XR configurations. Eventually, it turned out that none of additional XR configurations are needed, because all those provided by default and that has been downloaded from the Technical Linux are already enough. So the problem there was because the particular library that Xorg is using for detecting keyboard and mouse is called libinput. So if I just list the user local lib, do I have Xorg here? Xorg modules, yes, Xorg modules, and probably drivers. Yes, drivers. No, these are the video drivers. Okay, well, this is cool, but this is not. Where is my libinput? Let me quickly show. If I just go to, probably do find user local and grab for libinput. What? Oh, come on. That can't be true. Okay, just let's do the following: user local, find all. Well, this is so strange. Oh, crap. Oh, no. Oh. Libinput. Okay, xlib libinput cd lib probably here. Yes, xorg modules input. Yeah, here it is. So yeah, this libinput underscore drv.so. So this is the library. This is the particular library that is responsible for. Let me probably maximize this. That is responsible for. Just make this off. For user input. And the problem with this library is that if you don't have the Udev on your system, libinput is not going to work. Alternatively, you could have installed some older libraries like Xfbdev event device, and then would rely on the devices specified under the dev input and whatever event device. For instance, in my system, event 4 is keyboard, event 5 is mouse. So I just added some more events. I have no idea like one of these events are all about. Probably some maybe touchpad gesture related things. Maybe not. To be honest, I don't know. So it has been added automatically. But anyway, and also there are very old drivers that don't even support the hotplug. Event like hot plugin is not possible, but in that case you need to override the behavior of the X server, because by default it's not working with the non-hot plug drivers, although those drivers might be available in the system. So libinput works with Udev, and I needed to install the entire Udev stuff into the base. So let me probably show you that. So where was it? So under the bin, nope, onto the S bin maybe. Yeah, Udev Adam administrator and Udev daemon. So these are the programs. Under the lib, I have installed the Udev related libraries, and also under the lib there is a folder called Udev which has some. I have no idea what is this, but that was on the Technical Linux root file system. So just grab these things from there. And also Udev, if I'm not mistaken, it does rely on the folder called run. Yes, run/Udev. And this is the working directory that has been that had to be created. Oh, I don't remember whether there was something there already. Well, probably there was something already, because it's rules D. Let me just quickly see what is there. No, it's seems to be empty. Well, anyway, yeah. So whatever I found on the Technical Linux root file system regarding the Udev, I just grabbed that and installed on my system. And eventually, to make things run, I needed to change the very initial init script. So if I get the just open editor, probably better either. No, init. So eventually here I was mounting devtmpfs onto the dev folder, and that worked absolutely the same as it does with the U daemon. But and even if I still had the whole block in terms of, I don't know, I could have just plugged in the USB flash drive and it appeared under the devices. I could plug it, take it away, and it has been disappearing from there. Definitely the proof of the hotplug, if I understand hotplug properly. But anyway, so that I was forced to remove that. It was I didn't want to do so, but there was no other choice but doing that, and instead to populate all the devices with the Udev. That was the option to consider, so that the Udev daemon was start being responsible about the events related to updating the devices. And this daemon is also used by the X server when it uses the libinput library to initialize things. When the X server is initializing it in order to get the mouse, get the keyboard. I'll now show you the logs of the X server where that process is clearly seen. So these two lines what these two lines essentially do. So if you just list the devices, you see there's a whole lot of things there, including the sim links to standard error, output, and input descriptors. So this is what it does. It has entire folder with the sound, entire folder with the inputs, and so on and so on. So yeah, it does a whole lot of work here. So now, yeah, probably last but not least is to have a look at the. So I just do VICI and var log and xorg. So my workflow was the following until I had the Udev been installed. I was just running X server, hanging forever, pressing Alt print screen R to rescue the keyboard, then Control Alt F1 to get back to the first virtual terminal, then manually kill the PIDs for the X server and for the Joe's window manager, then start from scratch, reading through these xorg log, encountering a whole lot of errors there, and asking ChatGPT what to do with those errors, trying again. Yeah, that was like I didn't even know whether I would ever succeed with this or not. But anyway, so what interesting do we have here? So yeah, for instance, yeah, so default monitor. Well, I was specifying some custom configurations, but all those turn out to be not relevant because it just does everything it needs automatically, and that's just good enough. So I just want to show you it uses the mode setting module to deal with video, and then it finds the Intel drivers for graphics. You see. And if I'm not mistaken, these drivers are installed by when I install the package xf86-video-intel. I guess that comes from there. But also, for some reason, it also has the Xfbdev and VICI drivers being available on the way here as well. Well, eventually, it seems to be using the proper Intel drivers. Yeah, it even manages to use the DRI3 and 2, which is like the modern way to deal with graphics for faster rendering. If you're working with 3D applications or something. Yeah, eventually it switches the resolution to 1366678. 60 hertz on EDP1 screen. Yeah, it just creates this EDP1 screen, so it's no longer the dev /dev/fb0. Okay. What else? Video bus. Yeah, it even uses the libinput for VICI bus. I didn't know this. It's quite cool. I just want to find the place where it starts dealing with the yeah, already it's like it starts using it starts relying on Udev to configure things. Oh yeah, this is it. So for instance, yeah, the keyboard X input adding extended input device 80 translated set to keyboard. So just this is the keyboard which is on my laptop. So it just recognizes the particular like modal type, whatever. For the keyboard sets things here. Well, I have the US layout here, so probably that's the default one. Then what? Then it adds the ET PS to Elentech touchpad. Oh, it's even now it's at the event 11. Earlier it was at event 4 or mouse 0 device. Yeah, so it's probably Udev is like maybe Udev is creating some new. Or probably it seems like it's creating some new devices for some unknown reason. I don't know. Yeah. Anyway, so it does recognize the particular touchpad. So this lib input is really cool because again, like because without this drivers like on the bare Xfbdev without any specific drivers for the touchpad, I could only move the mouse pointer and I couldn't use the gestures like one finger is holding the button and another finger is moving the window. It wasn't the case. I couldn't just press and move very hard because it's not gliding. Yeah, and yeah, that was the scenario. But with this Elantech touchpad drivers, I can do whatever I can do on my Linux Mint. So like the same behavior. So I can click on a button, then use another finger to just move the window. I can use the left button, the right button. Earlier on Xfbdev, I didn't without these drivers for mouse. I didn't have the right mouse button click at all. Just didn't have that. And also I can scroll using the like two fingers gesture like this. It's really cute. Okay, so yeah, then it completes the DRI2 setup. So yeah, all the visit driver stuff here. Yeah, and eventually, yeah. So that's the log of the X server that is currently running. Yeah, it should be really kind of huge, I believe, because it's yeah. No, it's actually this is it. Yeah. So this is like the Xorg log here. Okay. So we are done with the most critical part, like what I've been through to set things up properly. And now probably one last thing to demonstrate. So I just want to let's probably so ALSA mixer. Let me quickly show you. Yeah, I just want to close the Firefox web browser. Yeah, simple screen recorder should be just working here. Okay. And yeah, by the way, it even prints this icon to show that it is recording, which is cool. Okay, what else did I want to do? Yeah, I want to show the rudimentary sound. So if I go to downloads, here I have this. Yeah, I'm trying to debug Cool Retro Term, which I've been recording videos on Linux Mint, but it's not yet working because there is still one Qt module missing on this system, so I cannot run it. But now I want to demonstrate to you this free test data WAV file. So if I say a play, so I have ALSA installed here, and yeah, well, sound is a separate territory, separate category. If I and now I'm struggling with installing Pulse Audio, like it seems like everything is working, but I still cannot hear the sound. Yeah. So if I ever manage to get done with this, because I don't believe that I will, like I didn't believe that I will get done with X server either. So if I ever get done with the sound, I'll make a separate video on what I've been through to configure that in particular. But for now, I just can show the how to play this free test data. And I'll now try to do this again and to make it louder. Hold on a sec. Yeah, well, you see, like, it gets a little bit louder. Okay, so that's the epic ALSA mixer, which I really like how it looks. I even made a shortcut for this right over in here. So yeah, apart from this, one of big, like really huge applications. Well, apart from Firefox web browser, which is obviously extremely huge piece of software, I also have the shotcut editor. So let me just run the shotcut. So this is the editor. This particular video has been edited under. So see, like shotcut boots, and I don't know if I have any files. Yeah, I have some simple screen recorder. So some tests that I've been recording already. Well, this one is apparently the one I'm recording now. So this should be the previous one. Let me quickly check this out. Yeah, it gets a bit laggy because I'm recording as well. Yeah, and I don't know. There should be the sound. There was the sound, or maybe this particular sample didn't have. But actually, ALSA sound works with shortcut, so I can just edit video here, which is really cool. I also use it as the video player. Also, I can use Firefox web browser as the video player and audio player and like viewer of the images as well. Not the best ever choice, probably, but still, so it works. So yeah, shortcut. Well, by the way, shortcut is probably the only package that I've contributed to the TinyCon Linux community. It has been remanaged after, but essentially, I was the guy who has compiled shortcut for x86_64 systems and made a post somewhere on the forum, just mentioned that I've created this extension and that it has been added to the official repository. So now we can have fun with shortcut, which is fantastic editor. Well, okay, guys, I think this is it from my side. I think this is really it. And yeah, we are stepping into the territory where all these never-ending configurations are starting being really specific to the particular user, particular hardware, because like in every different system I have different pitfalls. So the only reasonable thing I can still mention is like the overall approach, the overall direction of how to proceed. And just by relying on that, we can have the general understanding of the guidelines to like what to do, to get things done. So again, summarizing for setting up Xorg. So the most critical, most essential thing preventing things from working on my system was the lack of the Udev utility, like the Udev daemon, basically, that has been that has the purpose of populating the dev folder with the particular devices and listening to hotplug events on those devices. And libinput under the Xorg exactly relies on the Udev. Without Udev, libinput is not going to work, and the Xorg provided by the TinyCon Linux does not have any other libraries but the libinput. If it could, then they could have been specified manually, but they don't have those. Maybe you could have just, I don't know, compile one from scratch, and maybe that was the case. But yeah, so the least evil was to add the Udev. Now finally, monkey see, monkey do, Linux started being somewhat a practical system where I can do most of things that I could have done on Linux Mint. So I can record videos, I can edit videos. Unfortunately, I don't yet have the option to run my cool retro term. Not mine, but the one I like, yeah. I don't yet have the pulse out audio, so I cannot hear sound in Firefox, and workarounds like using APulse to mimic the pulse audio daemon. But essentially, that's the bare ALSA. It didn't work for me this time. It worked for me many years earlier when I was running this on the technical Linux, but now just for some reason it doesn't work. But anyway, so yeah. Next step is to deal with audio. Then we'll need to set up the web camera. I've recompiled the kernel, by the way, to support audio and web camera. And the current compilation of the kernel, by the way, should be recognizing lots of available hardware, because that's just the snapshot from the technical Linux kernel configuration. It takes a bit longer to compile, and the kernel gets really big. I'm not using kernel modules. I'm bundling everything directly into the kernel just for the sake of simplicity. So until I'm capable of doing that, I will be sticking to that approach, because I really like being like having everything in one place, like in one single executable, basically, which the kernel essentially is. Yeah. So that's kind of, so yeah, I guess I'm no longer taking your time. Thanks for watching. I hope you found something interesting and useful with this tutorial series. Yeah, you can congratulate me with finally having monkey see monkey do Linux being somewhat a practical thing. And yeah, thanks for watching. See you later, and cheers.